This is 2010 question number 3. It says there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. So automatically, the ride has not even opened yet, but there are 700 people waiting in line to get on. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. So people are coming and getting in line, getting on the ride, getting in line, getting on the ride. It says, while there is a line, people move onto the ride at a rate of 800 people per hour. So remember how we've talked about how units are very important. So if we look at the units up here, this is 700 people. So that's talking about the original function. So originally there were 700 people. This is talking about a rate. So people are moving onto the line, which means that the line is getting, onto the ride, which means that the line is getting shorter at a rate of 800 people per hour. So this is a negative rate because the line is getting shorter at a rate of 800 people per hour. It says the graph above shows the rate r of t at which people arrive at the ride throughout the day. So here's the graph. So people are arriving at a rate of 1,000 people per hour when it opens, gets up to 1,200 people per hour when it's been open for 2 hours, goes down to only 400 people per hour by the 4th hour, so on and so forth. It says time t is measured in hours when from the time the ride begins operation. So again, let's look at what we're given and look at the units. We're given that 700 people start in the line. That's original people, so that's the original equation. We're given that the line is dying down at a rate of 800 people per hour, because that's how fast people are getting on the ride. And then over here, we're given this rate that people are getting in line. So obviously it's dying down at a rate of 800, but then the rate that people are getting in line changes. So, the number of people in line will be constantly changing. Part A, how many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer. So, people are arriving to the ride at this rate. So it's obviously always changing, but we can figure out how many people have arrived to the ride if we look over here. Units. They say how many people. So if this is in people per hour, if I multiply people per hour times hours, that would give me people. So essentially I'm trying to find the area under the curve between 0 and 3, which would be this area right here. And if I can find that area, then that gives me the number of people that have arrived to the ride between when it opened at 0 hours and when we are looking currently at 3 hours. So if you guys can look over here with me at these computations, we can see that, again here, the integral from 0 to 3, the area under the curve from 0 to 3 of this function, and I just used like breaking it up into rectangles and trapezoids and triangles and that kind of stuff. So when I did that and I broke it up, I got that there were 3,200 people that had arrived to the ride after 3 hours. And so again, I like to do little unit checks, whether or not it's in my head or on paper. But notice that r of t is in people per hour. Then I took the integral to multiply it by the time, which is in hours. And when I do that, it cancels out to just be people, which is what I want my final answer to be. So I know that that was a correct way of doing this problem. Part B. Oh, by the way, that one was worth 2 points. You got 1 point for actually writing the integral, that you're trying to find the integral from 0 to 3, and then of r of t, and then 1 point for the actual answer. Don't ever jump straight into the answer. Always try and show the setup of what you're doing first to make sure. I mean, if you have to, of course, you can jump straight into the answer if you don't know how to write this, but try to write the setup first to make sure that you're communicating what you're doing in that part of the problem. Part 2 says, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. So again, let's kind of come back here again. We were given two sets of information about the number of people waiting in line, or the rate at which people are waiting in line. The first set of information we were given about that is that people move on to the ride, or in other words, they leave the line. So this is a negative rate at a rate of 800 people per hour. And over here, we're given a rate at which they come to the line, so they get in line. So this is a positive rate. This is always increasing in area, so more and more and more people are coming. And over here, this is a negative rate, so we're decreasing the line by 800 people per hour. So it says, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? So because we have a negative rate and a positive rate, we can't just look at one or the other. We have to look at a combination of the two. And here's kind of how I would like to do it as a combination, is that if this is our positive rate, and we're literally going to subtract out 800, so if you think about it like this, if you think about it like, you're taking r of t and subtracting out 800, it's kind of like shifting the graph down 800. So if I make a new x-axis about right here at 800. That's kind of like I shifted it down 800. And so essentially what this means is that whenever this rate function, r of t, whenever it's above this purple line, that means that people are being added to the line faster than they're being subtracted to the line, or subtracted from the line, I should say. So all of these values between 0 and 3, the line is getting longer because people are coming to the line faster than they're leaving it. Everything after 3, however, notice that it's all below 800. So because of that, people are not coming to the line as fast, which means that they're leaving still at a rate of 800, way up here, but they're only coming at a rate of 400, for example. And so the line's getting shorter everywhere past 3. So it says, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Well, because t equals 2 and t equals 3 is above that purple line, it's above 800, that means that the line is getting longer. So the number of people waiting in line is increasing because r of t is greater than 800 at that moment in time. So that is worth 1 point. So the answer with the reason is worth 1 point. Again, the number of people waiting in line is increasing because people move on to the right at a rate of 800, but r of t is greater than 800, which means that it's outweighing that negative value there. Part C, at what time t is the line for the ride the longest? How many people are in line at this time? Justify your answers. So, again, this kind of comes back to what we were just talking about with this imaginary purple line. So if you take into account the fact that people are leaving the line and we kind of draw that new x-axis here at 800, you can think of it as, so remember at the very beginning, there were already 700 people in line, and then the line starts increasing and getting bigger and bigger, 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 bigger. Even though the line starts decreasing, people are still adding to the line at a rate faster than they're leaving, so the line's still getting bigger and bigger and bigger and bigger and bigger. And then all of a sudden here, notice that we have this point where our graph goes from positive to negative, because I made this my new x-axis, and now it's negative down here. So on the original graph, this would have been something that was increasing and then decreasing. So that means that this point here is kind of like that break-even point, and that happens to be a maximum because we're going from positive to negative. So this is the maximum, or in other words, when the line is the longest. So remember that we started with 700 people, and then we are adding however many people have come to the line between 0 and 3 hours, which we actually calculated in part A. But then you also have to subtract the number of people that have left the line between 0 and 3 hours. So let's look at all three of those together. So again, the first thing they wanted to know was they wanted to know at what time the ride was the longest, the line for the ride was the longest. So identifying that t equals 3, you get 1 point for that. And again, that's because that was the break-even point, so that was the maximum. Then we want to go ahead and tell the number of people in line, which ends up being 1,500. So here's where they get that from. Let me highlight the three different pieces. The first piece, let me make that a little thinner. The first piece is how many people were starting in line. So 700 people started in line before the ride even opened. So we got to count them. This 3,200 people is the number of people that accumulated. Notice again, we got that from part A up here. That's the number of people that accumulated to stand in line as well. Between 0 and 3 hours. And then this 800 times 3 is the number of people that left the line to go on the ride. So 800, obviously, because that's the rate that they're leaving, and then 3 because that's how many hours that have passed. So 800 times 3. When you add and subtract all these numbers, you get 1,500 people waiting in line. And then the justification, again, is that because r of t is greater than 800, that the breaking point here, it's 3 because it's greater than 800, less than 3, but smaller than 800 to the right of 3. So again, that's worth 3 points. And then last but not least, it says write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. So let's kind of break this one down. First of all, we're looking for an integral expression of r. So it's going to be something with an integral of r in it. And the solution, so what it equals, would be the earliest time t at which there is no longer a line for the ride. So let's kind of break down what that means. No longer a line for the ride literally means that there are 0 people in line. So let's start there. There are 0 people in line. Okay, well, let's see. Obviously, we're going to write an equation for this. And let's kind of see where t goes in our equation. So let's start with how many people were in line to begin with. There were 700 people in line to begin with. And then we started adding people. So from when the ride opened at 0 hours to some time t, we don't know what time t that is, but some time t, people are being added to the line at a rate of r. Now normally we use r of t, but again, remember how we said that we don't want to confuse it with two of the same variable? So you can change this variable to anything you want. I'm going to change it to an s, as long as you also change this to an s. So it was a t up in this example up here, but now I'm just changing it to an s because I don't want it to confuse it with this t. So here's what this means. 700 people were in line to begin with. Then we're adding people to the line at a rate of r of s, and we want to know how many people have added to the line between when it opened and this certain magical time t that we don't need to solve for, but we know that it exists. So at some time t, this is going to all add to 0. All right, so far these are both positive values, so you're wondering maybe how are these going to add to 0 if we're starting with a positive value and we're adding people to it. And remember, that's where that 800 comes in. So we're subtracting out at a rate of 800t the people that are leaving the line. So remember that if this was after 1 hour, this would be 1 and this would be a 1. So we would find the integral under the curve from 0 to 1, and then we would say that 800 people had left in the first hour. Now, we don't need to solve that, luckily. So we don't need to figure out what t is. We just needed to write an integral expression involving r, which we did right here, that gives us a solution if we did actually solve for t. The solution for t would be what would make this equal 0, or in other words, that nobody would be waiting in line anymore. So let's look at the points for this one. The 3 points as well. You get 1 point for getting the 800t, 1 point for getting the integral of r of s, and 1 point for getting the answer of 0 equaling that whole thing added together. So that's where you get those 3 points from. So that's number 3 from the 2010 exam.